Good evening everyone. Welcome to week 6 of Data Science for Engineers course. I am Elsa Sharu Johnson from NIT Tiruchirappalli, and today we'll be discussing assignments of previous run course. So in this week, I'll just go through the contents which were taken in this particular week. So the title of that was Predictive Modeling, and you have seen how to calculate the sample means, sample variance, covariance, then different correlation values like Spearman rank correlation, Kendall rank correlation. Then you have looked at certain error values, then how to plot a linear regression model, and then how to see whether the model that you have plotted is it has correctly fitted the data, or are there any non-linear relationship present in which you have to change the linear regression model, how to see whether the model is fitted rightly. So all these things you have looked at the present week. So today we'll be seeing some assignment questions related to that. So in this particular week we'll be using more of RStudio to solve the questions, and some of the questions can be done by normal calculation itself. So I'll be switching on in between with the presentation and the RStudio window so you can see. So we'll start with the first question. So the first question is, for the following set of questions 1, 2, 3, 4, 5, use the dataset bonds.txt. This dataset contains two variables, coupon rate and bid price. So for those of you who had gone through the lecture videos, you might have seen this bonds.txt already, this particular dataset, and it's given in your course window also. So you can download this particular data named, it's a text file containing about 35 observations between the coupon rate and bid price. Okay, so if you just, it's a publicly available data set, so if you just search for bonds.txt, then also you can obtain this particular data set. So first what we have to do is we have to install this particular data. So I have given the link also from where you can download that. So it contains the same link as given in your window. So when I share you this PPT, you can look in that, or just you can go to your course window and see that. So the first thing asked is, what is the relationship between the variables coupon rate and bid price? Okay, so what we have to do is, so since it's a data set, we'll move on to RStudio, and there right now I have the first one. Okay, so I'll just I hope the screen is visible for you, so I'll just maximize the figure, and okay, I think it's visible. If anyone is not seeing the figure, you can let me know in the chat window. Not the figure, I mean if you can't read what is written, you can let me know in the chat window. Okay, so what is the relationship between the variables coupon rate and bid price? That is the questions. Okay, so first we have to read this file to a particular name, variable name. So I'm giving bonds and I'm reading using this particular command delim, and this is the command inside that selects the file known as file.choose and row.names equal to 1. So this is like first row should be taken as the header file, that is what is given. So in this one I have bonds.txt, which is a text document with size 1 KB. So I am opening that. So right now you can see that this is the bonds.txt, coupon rate and bid price is there. Okay, so these are the things. Okay, and about 35 observations are there and 2 total columns. Okay, now we need to form a models, because the question was like, what is the relationship? So relationship means here it's a simple linear relationship is asked. So, and in this present course also, present week also, we have seen the linear regression itself. So what we'll be doing is we'll be using the LM command. So it's like formula, data, subset, weights, all these things are the parameters or the arguments in that function. So we'll be putting the name model underscore 1 and equal to LM of bit price, and this is the formula, bit price, coupon rate, and data equal to bonds. This is one way where you can give this one. Okay, so just I will enter that model 1 equal to bit price and coupon rate, data equal to bonds. Another way to do this is you can copy the same, I'll copy the same thing, and you can put here bonds. So right now I have put it like bonds dollar bit price, and this one as bonds dollar coupon rate. Okay, if you give like that also, then just if you give like that also, you can do the regression model. Okay, so just anyway we'll be looking at model 1. Okay, let this be put aside. Okay, sorry. Yes, so model underscore 1 right now is the linear regression model, and I'm just printing the model. So the model right now, when I print that, I am getting the values as the formula is bit price with coupon rate, and the coefficients are intercept, which denotes beta naught, and coupon rate is beta 1. So if your equation is like y equal to beta naught plus beta 1 x, then it's like 74.787 plus 3.066 into coupon rate. Okay, so you have got, so what is the relationship was asked. So the relationship can be obtained as bit price equal to 74.7865. So right now it's not 7865, but anyway similar to that, 74.787 and plus 3.006 coupon rate. Okay, so this is the answer. Okay, so I think the first question is clear for you. I'll move on to the second question. Choose the correct option that best describes the relationship between the variables coupon rate and bit price in the given data. So you can give this answer. Just you can put the answer in the chat window. What have you felt? How will this answer be? What will be the answer? Because you have got here 74.787 plus 3.066 into coupon rate. So from this itself you can see how it is related. Is it a positive or a negative correlation? So one has put A, okay, one has put C. Okay, just so right now what we have got is like this one. So our bit price equal to, so instead of beta naught we have 74.786 or 787 something we have got, plus 3.066 into coupon rate. Okay, so it's like from here itself you can say that you don't have to like a good look at the correlation. Actually, to do these things you have to look at the correlation. Okay, so correlation, how you can see is COR. Okay, bonds, so we are seeing the correlation between the coupon rate as well as the bid price. Okay, so coupon rate is the independent variable and bid price is the dependent variable. So with this one, I'll just run this particular thing. So you are getting 0.866. Okay, so you can see here, this is the thing, and correlation between your bid price and your coupon rate has come as 0.866. okay, so this means, so anything which is greater than, you can say 0.7, it's not 0.5, you can say that it is like a strong positive correlation. Okay, so the answer actually will be strong positive correlation. And if it's like less than 0.5 and is it the positive value, then it will be a weak positive correlation. If it's negative values, then you will be having strong negative or weak negative correlation. Okay, so anything which is close to 1 to positive 1, okay, so anything which is close to positive 1 will be a strong positive correlation. So in this answer, the answer will be strong positive correlation. The answer will be A. Okay, now next question. So I think it's clear. Okay, we have seen the correlation between the values. How to calculate this one was told in the last class. So correlation, the arguments to be given are this one. If you, okay, so this is the correlation. You have seen all the different methods of correlation that can be found. So the first one, like Spearman, Pearson, Kendall and Spearman, you have seen, and wherever these are used, like when ordinal variables are coming, what we'll be using, all those things you have seen in the thing. So here you can use, since the variables are like numerical values, you can use the initial one itself, Pearson's correlation itself you can use. Okay, now the next one is, what is the R squared value of the model obtained in Q1? Okay, so we are asked with the R squared value of the model. So we can get the R squared values in different ways. So I'll just see the summary of the model 1. Okay, so summary of the model 1 will give you the R squared value as well as the adjusted R squared value. So in this summary, you might have seen, like in the lecture videos itself, you might have seen I have given, this is like the fitting model. So bid price with coupon rate and data taken from bonds, that was our model. Because we have put the model summary of the model 1. This is the residuals, which was like the prediction minus the y bar. So that much you have got the 5-point summary for that one. And then you have seen the coefficients, so which is the intercept as well as the coupon rate. So here intercept was coming like this and coupon rate was like this. So the standard error of that, the t-test value and the p-value for that, and how much significant it is. So it's like both these things, the intercept as well as the coupon rate, are significant. Okay, and the p-value for the whole thing prediction has been given in this range, which means that our particular model is for our particular model, the null hypothesis will be rejected and the alternate hypothesis is valid. That means that the intercept as well as the coupon rate are significant. Okay, that means beta naught and beta 1 are not equal to 0. That is the meaning. And in the present question, the R squared value and adjusted R squared values are given. So this is the R squared value and adjusted R squared value. So in our question, we were asked with the R squared value. So the R squared value was 7.7516, right? So I think you have got the answer. Okay, so what you can do is, if you are not having the particular model, okay, you can go to your course window and you can download this one, and you can type these particular statements. Okay, just find that, and let's move on to the next question, which deals with the adjusted R squared value. Okay, so the adjusted R squared value also can be obtained from the same model. Okay, so the adjusted R square value, okay, that also we can find from the model. So one option is there, 0.7441, that also is available here or have been obtained in this particular answer. So adjusted R squared value is this one. So in any case, if you want to see, if you are given with two sets of data and you want to see what is the answer, for that only I have given an extra problem. So it's like I have given x value as a list of 80, 75, 85, 70 and 65, and then y values I have given like 85, 70, 80, 95 and 70. Then number of observations, it's like 5. So to find that coefficient of determination R squared, first I will see different like SXX value, which is sum of x squared value minus sum of x the whole square by n, and SYY is sum of y square minus sum of y the whole square by n, and sum of xy like sum of x into y minus sum of x into sum of y by n. So all these three I will run. So these values will be stored. SXX is equal to 250, XY is 50 and YY is 450. Then with these values you can find out SSE, that is SYY minus SXY square by SXX. This you have seen in your course video. Okay, these particular formulas you can write these down, and R squared value can be calculated by SYY minus SSE by SYY. Okay, so if I do that, R squared value is coming in this way, and I'll just round the value to 2 decimal points and then I will print that. Okay, so first the value is printed and it is rounded again to 2 decimal points and printed again. Okay, so this is the R squared value. Now if R squared adjusted is asked, there are two formulas for that. Okay, which when you find, when you search in the web, you can get two formulas for that. So one is 1 minus R square into length of y minus 1 by length of y minus 2, and if you give that, you can get the R squared value as this one. And again, this is the another one where R square minus 1 minus R square into like this value. Okay, so same values will be obtained. So I have given you the links also, so that you can see from where you can calculate in this format. Okay, then we'll move on to question 5. So initially in the present question, in the assignment question, it was asked like what is the adjusted R square value of the model. So it was directly obtained from the previous summary of the model. But even if you are given the values like this, what you have to do, I have just told you. Okay, so here also, in any case, if you are asked to calculate them on your own in the exam by giving a set of values, then you have to calculate in this form, seeing these formulas. All right, and so the adjusted R squared value will be, for the particular question, it is 0.7441. And the next one, based on the model relationship obtained from Q1, what is the residual error obtained while calculating the bid price of a bond with coupon rate of 3? Okay, so I am given, so right now we have formed a model which gives like your bid price, which is the y value, is equal to beta naught around 74.7865 plus 3.066 into coupon rate. So this is our model that we have fitted right now. Now we are asked the coupon rate as to be 3 actually. So in our example, the bonds model, so it's like when coupon rate was nearby, okay, 3 value is already there actually, the bid price should come in this way. Okay, now we'll see how our model is predicting. Okay, so for that I am just putting in a new data frame coupon rate equal to 3. So I am putting it in A. So A right now contains the coupon rate value as 3. And result I am putting predict. Model 1 is the model that we have fitted and A is the value that we are going to predict. So when I am putting that, I'll print the result. So result with the model is coming like in this way, okay, 83.98487. So in this one, in the question we are asked with the residual error. Okay, so right now we got the answer as 83.98487. So it is like 83.98487 is the value that we got when coupon rate was 3. So this is the predicted value, you can say, and the original value, okay, the original value we can obtain from the data. So 3 at 3 it is given as 94.50. so if you see here it is 94.50. then what you can do here is you can, for the residual error, I'll write in this way, you can subtract it. Okay, so you can subtract and give the answer. Okay, so in this particular case the answer, so you can do like answer will be A. Okay, one of you have put, so I'll do that in this RStudio also. It's like 94.50, which is the original value minus the result we have obtained, and I am printing the error value, which is 10.51513. so this is what you have seen. So it will be 10.51513 actually, but okay, it's coming like that, but the closer value to this one is this 10.5155. okay, so A is the answer. So I hope everyone's clear with these first 5 questions. Okay, so I'll move on to the next one. State whether the following statement is true or false. Covariance is a better metric to analyze the association between two numerical variables than correlation. You can put the answers. Which is a better metric? Is it covariance or correlation? About covariance and correlation we had seen already in the last class, like one will show direction and strength, and the other one will show just direction. You can just put T or F. Okay, yeah, correlation is better, that's true. So correlation is a better metric to determine the association than covariance. Okay, as correlation does not have any units and it's also not dependent on any range of values of the variables. Okay, Yeah, so answer is false. Now if r square is 0.6, SSR, that is the residual sum of squares, then total sum of squares as 500, then sum squared error is asked. Okay, so for this one I think you can use the equation, or just I'll move on to the RStudio, so you can look at the values. So right now here r squared is given, so we had seen the relationship between this one. Okay, so for this, what will be the answer? So I'll start. So whatever we have given is r squared, we have been given with is r square is 0.6. Residual sum of square of the sum is 200. SST is 500. This is like, so SSE is asked. Okay, so what we relationship we have here is SST equal to SSR plus SSE. So I have got answers right now. So to find SSE, what you have to do is SST minus SSR. Okay, so that will be 500 minus 200. The answer is 300. Okay, I've got one answer as A. Is it clear for you? The answer is C. Yeah, okay. So this is the solution. Now the linear regression is an optimization problem where we attempt to minimize. You can give the answer. C. Okay. SST. One of you have put two answers. Actually we will be seeing to, yeah, it's not B. We'll be looking at reducing the sum squared error, because what was sum squared error? It was like yi summation of yi minus y cap the whole square. What is in prediction? Actually we'll be having the original value and we'll be having the predicted value. So difference between the original one and predicted one, so the square of that, and then the sum will be the sum of sum squared error. So that will be where we'll be trying to reduce that. Okay, and then to see whether it's fit for our problem, we'll see the residuals, and then only we'll be doing the other things. So linear regression is like we attempt to minimize the sum squared error. So the answer will be C. So I've written this one, minimization of yi minus this one will be the predicted one, yi minus y cap I can give. I hope that's clear. Okay, so now we have a set of points. The model built from the data given below is, so model is already given, like y equal to 1.39 x plus 6.09. Find the values for r square and adjusted r square. So this one is the way in which we have already done that. Okay, so earlier we had seen a problem. So in the same way we can do the next one. So I have written it already. So correlation we had already seen. Correlation, if I am doing that, so these particular values, okay, so I'm just, I mean, since we are in this question, just I have two sets of values x and y, and if I put correlation xy, and I'm getting very strong negative correlation, so this is like very strongly negatively related. Okay, so anyway, moving on to the present question, I'm having the set of points, so 8.55, 0.32, 8.4, 6.96, like that I have given the values. So I am giving this as a list and storing in x, and then the y values I have 17.03, 6.19, so this also I'll be storing in this particular variable. X and y is right now stored with these values. Now we know that the number of observations here that we have is 1, 2, 3, 4, 5, 6 observations we are having, and so I am giving n equal to 6. And so the steps we had already done, right? So you have to find sxx, syy, sxy, okay, the same steps that we have done for a previous question. Okay, so I'll just run through these steps. So sxx you will be getting, in this particular case, I'll clear the variables once so that you can freshly see that. So the present question, in the present question, x is this, y is this one, and n is the number of variables as 6. I hope you can see this in your window. Then sxx is right now sum of x square minus sum of x whole square, total divided by n, so you'll be getting it as 57.8502. now syy, in the same way you will be getting 118.10935, and sxy, sum of x into y minus sum of x into sum of y by n, this value you will be getting like 80.433. so you can see the difference from the previous question, right? So the coefficient of determination, r squared value, you can get in this way. SSE, first you can calculate by syy minus sxy the whole square by sxx. So SSE you are getting like 6.27, and r square value is syy minus sse by syy. Then you can round this to 2 decimal places and get the final answer as 0.95. okay, so 0.95 is the answer of r squared. Then the next one is adjusted r square. Okay, so there is another option which is given like alternated. So r square here is given as 0.93 and adjusted r square is 0.95. so we'll see the adjusted r squared value also. So for that, just like earlier, we have two equations, so one of the things we will run, and now I'm getting like 0.9335, that is the adjusted r squared value, or if you round it to 2 points, then I'm getting 0.93. so in our particular answer in this question, r square is 0.95 and adjusted r square is 0.93. so just I've put the snippet of the code which needs to be used. Okay, this you can access later. For those who can type now, can do this and see for yourself also if you have the question with you.
Hello, ma'am. Good evening, ma'am.
Yes.
Ma'am, do you have for the first question also this snippet code, ma'am?
First question.
Yes, ma'am.
This one. Is this the
Yes,
one
ma'am.
you are asking?
Yeah, yes, ma'am. Yes, ma'am.
Okay. That I'll put the snippet after the class.
Okay, ma'am. Yes, okay.
Yeah, this is the code. Okay.
Okay, ma'am.
Yeah, I can. Okay, I'll put that after the class. You can just
Yes.
see that.
Okay. Now we'll execute this, ma'am. Thank you.
Okay then. I'll just put this window for some time, okay? You can type that. Just you can confirm if you are having the bonds text file for you, or okay, yeah. Otherwise you can just go and search in Google, just bonds.txt. You can search also. It's a file which is widely available. Okay, I hope it's okay now. I'll move on to the next question. Just you can put a thumbs up or yes anywhere. Okay. So we were looking at not this. Yeah, this is the question. This was the question. Okay, the next question. Identify the parameters beta naught and beta 1 that fits the linear model beta naught plus beta 1x using the following information. Total sum of squares of x is denoted in this way. Okay, so in our notation it is like SST, right? Or you can say that it like SSX. Okay, so anyway it is like 52.53, then SX XY, okay, that is 52.01, and mean of x bar is given as 4.46, and mean of y is given as 6.32. okay, so the notation there is not right anyway. So in this one we have to find the answer. Okay, we have to find the identify the parameters beta naught and beta 1. So for beta 1, okay, you can get it like Sx xy by SSXX. okay, so that will be 52.01 by 52.53. you can calculate and tell the answer. So it will be around, anyway it will be around 0.99. okay, so that option is there right now. Okay, one option is there. So right now we'll see for beta naught also. So beta naught anyway, so it's like you are given with the x bar and y bar values. okay, so this itself can be used because you don't have any other x or y values. And so what you can do is, so you are given with the x bar and y bar values, so depending on that only beta naught is calculated. So for this one you can have y bar minus beta 1 x bar. It's a direct question. All the mean values are also given. You are not given with the x and y set of values. If those were given, you have to calculate the x bar and y bar values. Okay, so right now we have this one, right? So y bar value is 6.32, and beta 1 we have already found like 0.99 into x bar is 4.46. so you can calculate the answer. It might be coming close to 1.9. okay, just check the answers. I'll give you a moment. Okay, so this is the answer. 1.9 is the answer. I'll remove it from here. Okay, so the answers are 1.9 and 0.99. So actually, are there any different questions from this? I'll go through some extra questions also, but in the previous assignment as well as the assignment conducted before this one, that means July 23 as well as Jan 23 had the same set of questions. Okay, so since this is like mostly done in RStudio, the same set of questions were there in 2 sessions. So I have kept some extra questions. We'll see the answers for these questions also. Okay, so choose the correct option that best describes the relationship between variables x and y in the given data. So the data is given as -2, -1, 5, -5, 2 and -3, -4, -10, 0 and -7. Okay, so this you can calculate in the RStudio also, as well as you can see this, do this separately. So we'll move on to the RStudio first. Okay, so in this one I'll move on to that particular question. So this is the particular question. Okay, no, okay, wait a moment. Correct option that best describes. So it is asked like randomly sampled, positively correlated, negatively correlated, none of the above. Okay, so this question I had already shown you what is the correlation for some other question. So you can say how it is correlated, whether it is positively or negatively correlated. From the data itself, you can see that yes, the answer is right. As the values are increasing, just -2, -1, 5, -2, -1, 2, 5, within this itself you can see the relationship as it is negatively correlated. So anyway, just I have given like this set also. So first I'll run this one, -2, -1. So x values are being stored and y values have been stored. Just I give you, if I give the correlation, it gives like -1. So from that itself we can observe that it is negatively correlated, or directly looking at the samples also you can see that. So the answer here is negatively correlated. Now the model built from the data given below is, so we have data also and model also. So I think you have seen this question already. Okay, this question was seen already. Just I have put it directly here also, and our objective is to calculate the R square and adjusted R square. Since it's like repeatedly coming, I'll just run these things. So x and y values are given like, sorry, this is a different question, but this is the same way in which you have to do this one. Okay, so for the present question, I think I have given in a different file. Yeah, this is the question, x equal to c 80, 75, 85, 70. So we have already seen that, and you can give the answer now. So I'll directly run all the other values. You can say the answer for this one, right? if you have opened your RStudio window, you can type these and get the answer. Just I'll minimize this window. The other way you have to do is calculate the x square, calculate the y square, and the sum of that you have to calculate, and finally arrive at the answer. So for calculating it manually, you have to learn all these formulas. So you can put the answer. None of these? Okay. So anyone else? So I will run everything together. So answer coming is 0.02. You can see here, right? So the answer coming is SSC was 440, XX is 250, and XY 50 and 450. Okay. Then the R square value coming like 0.022, like that, and adjusted R square I have calculated by two methods. Okay, I have told you already. So it's coming like -303. So if you are rounding it to 2 decimal points, is coming like 0.02 and 0.3. So you can see that it's not asked with 0.2 decimal places. Okay, so you can say R square is 0.022. okay, just look at that, 0.0222 it's going. So 0.022, three of them are having that answers. Adjusted R square is given like -0.0303, 0303. So that one we see that it is 3037. So here you can give it as 303.03. So the answer will be A actually. Karthik, are you clear with the answer? Okay. So the next question will be, for the following set of questions 5, 6, 7, use the data set women.csv. This data set contains two variables, height in centimeters and weight in kgs. Okay, so what is the relationship between the variables height and weight? So for this I will move on to a separate file. So okay, so for this one, okay, so I have right now, it's saved as, you also might have this file, right? women.csv, that is the file. So if you look at that file, it is like this only, height and weight. So looking at the file itself, you can see that, if I can increase the size, so you can see that anyway the height and weight are actually misplaced. Okay, but anyway, forget about that. This was a file which was given earlier, so that's okay. Just do the calculation according to that. Okay, so this is the file, and what I'll do is, like, you can use the same function which you used, read dlim, or read, this is CSV, so read.csv, like that. You can put files choose also, or you can directly give the path. So right now I know which is the path to be used, so this is the path right now, so I can copy. So in this way, if you want to put, just you can copy that and paste that, and you can see which is the path, okay, file path. But one thing you have to do is you can change this backward slash as forward slash when you are mentioning the path here, okay. So this one, or another way is like you can put double backward slash also, but anyway the one thing which is followed is the single forward slash, okay. So forward slash you should put for your paths, okay. So the path is defined right now. If this particular file is the file path is already, the current directory is already at the same place, you need not mention that. You can make the directory as the same as the file, but anyway if you give it like that, anytime if it changes also, no problem, it will go to that specific location. So for that, anyway I have given it like that, and row dot names equal to 1 I have given because the first row is the header which has the column names. So anyway we'll move on to solving this one. So data, it's CSV file, so read.csv, okay. And the model 1 itself I am naming lm, which is our linear regression function. So it requires a formula. The formula right now I am giving like weight with height, okay, and data equal to data, like this you can give, or directly you can take like data $weight and data $height. So this time anyway I am giving in this way. So print the model has been printed like this one. The intercept is -87.52 and height beta 1 value as 3.45. so in our question just the relationship was asked, -87.51667 and 3.45, okay. So that is the values, okay, 3.45 minus 87.52. so just so the thing is the first value, okay. So I have given the snippet code snippet also. So this is what we'll be getting. The answer is A. Please explain row equal to 1. Okay, if you give row equal to 1 only, then your first row will be taken as a column name, okay. So just if I just put here like data 1 read.csv, I am not putting anything, okay. row.names equal to 1, I am not putting anything, and I am just running this one. Then data 1 will be given in this way, okay. So you can see here one extra thing has come. Just I'll put the other one also. Data, see the relationship, not the relationship, see the difference, okay. Earlier it was like in the initial file it looks like this. There is one row which is like unnamed. In Python you can see it like unnamed equal to 0, okay. So this particular thing is removed, which is like a serial number, you can say. This particular row was serial number. So when it was like removed, this came in this way. One particular extra thing has come up, and then this is the difference. I think you can understand now. Yeah, so okay, so we were here right now. So I have put that as data 1, so no problem. Data is already read.csv, this one. Anyway, so model 1 is fitted with respect to data, and now what we'll do is we'll plot. So for that I'll move on to the other thing, okay. So right now the first one was the relationship. The next one asked is the r squared value, and other than that the adjusted R squared will also be asked. So anyway, I have put the snippet of the summary. So summary was giving like residual standard error as 1.525 on 13 degrees of freedom, and R squared value as 0.991. so that is already there, and adjusted R squared value also you can calculate, but anyway it's not asked anyway. So if it is asked like this, adjusted R square value is coming like 0.99 and this is 0.991. okay, so you can see that the R squared value for the model fit in between the variables weight and the height is found to be 0.991. okay, the answer is B. So in the code also, if I just put a summary, so right now it is in this way. We have just seen the model only. So if I am putting like a summary of the model, okay, so summary, I'll just type of the model 1, okay, model underscore 1, and if I am giving that, you can see, I think you can see the answer here right now. okay, the whole, so this much small snippet only I have given. So I think one person who had asked about the earlier coupon and bid price thing also, question also, you can check this one also, okay, with the another data set. So here you can see that the intercept value has come like 0.8751667 and the beta 1 value is 3.45. the error, standard error, the tree value, as well as the significance. So the significance, actually these two values are very much significance, meaning like beta 1 value is not equal to 0 and beta naught value is not equal to 0. Then you are getting the R squared value as 0.99 and as well as the adjusted R square also as 0.99. so it's like very much close to 1. So you can say that based on the R squared value, you can say that your model has fitted very much nicely. okay, so since, okay, so before doing this question also, we can just see how the data looks like. So for that, what I'll be doing is I'll plot the data points with weight and height, and I'm just putting the color as blue, then the title of the graph as height and weight regression, I'll give that, and the line to be drawn with respect to the model that we are using, and certain other values which will see the font values, okay, font size and all. So if I do this one, if I plot this particular thing, sorry, it is giving like figure margins are too large. So what I'll do is I reduce the size of the environment, and then again I will run this particular model. So you can see here weight and height. okay, so just I'll export, and this is the plot. okay, I think it's better if I keep it like this. okay, yeah, so this is the height and weight regression. Just okay, better than this one is this one itself. okay, so you can zoom also, just the plot. Okay, I think it's clear for you now. Okay, this is the figure height. Okay, I have written it differently, just wait a moment. So height in centimeter and weight in kg. So anyway, okay, so this is our model and this is our graph and the zoom. Okay, this is the zoomed value. Okay, so height in centimeter and weight in kg I am giving. Okay, so here just I have named it differently. All right, so here you can see it's kind of having a straight line relationship itself. That is why when we have made a linear regression model, the r squared value is coming very close to 9. So if I do the summary also, it is showing, we have already seen that it's 0.991, right? So this is the reason why this is, this is like kind of having a straight line itself. Okay, so that is why we are getting a very high r squared value. All right, so I think that's clear. Now the next question is based on the model relationship obtained from question 5. What is the residual error obtained while calculating the weight of a woman with height 69 centimeters? Again, don't look at the values. Okay, so here we have to predict for a height value equal to 69. So first I can go to the data first. So data, right now you can search and see whether 69 is available. Yes, for 69 it's given as 150. Okay, so with that first, okay, that is the original value. Now we can predict what it is looking like. So this we have already done for the coupon and bid price problem. So first I'll put it to A as a data frame as height equal to 69, and then the result I'll be storing as predict from the model 1 and A. So if I am printing the result, I am getting as 150.5333. So you can see here it is close to 150 because in that data itself for 69 the answer was 150, and the model which was fitted with the linear regression model predicted it as 150.533. okay, so it's closer, and if someone is asking you for the error, you can just do it like result minus 150 and the error can be printed like 0.533. so it's a very close model. Okay, so that is this one. So I have already given that. Okay, so residual error was asked in the problem, so it is answer D, 0.53333. okay, now you can answer this one. The higher the value of r square for a model, the observations are more closely grouped around. So we have seen from the previous example also where it will be closely grouped around. We have seen actually two questions. Okay, the first question, which was the coupon bid price. Okay, so in that one, when we I will run that also and come back to this again. So bonds.text, it was that one. Okay, so coupon rate and bid price, the r square value was coming like 0.7516 and adjusted was coming like 0.74. and right now in this particular problem, I will run that. So right now it is coming like 0.9903 is the adjusted r square value. So from this itself you can see the earlier value was looking like this. Okay, and the coupon price problem is looking in this way. You can see the line was fitted there, but still it's kind of varying. There are outliers also, and it's not following a complete linear relationship. In the women.csv data, it was following a linear relationship. So that's the reason why you have got a lesser R square for this coupon rate and bid price, which was like 0.77, kind of closer to that. So from this you can say, from this also you can say, the higher the value of R square for the model, the observation are closely grouped around, you can answer that. Okay, I've got the answer B. So that's right. Yes, I think everyone's agreeing with that. So the standard assumption of all ordinary least squares regression is that, what is the standard assumption? There are no errors in measurements of independent and dependent variable, or there are errors only in measurement of independent, or there are errors only in measurement of dependent variable, or there are errors both in measurement of independent and dependent variables. This is dealing with the measurement of independent and dependent variables. Okay, so when you are trying to fit a model with a regression model, what is the first assumption that you are making? Whether there will be errors, or does the assumption doesn't contain any errors? This is kind of a basic thing that you will do. So even if you are getting a simple data set, you will be first checking whether the data has any missing values. Okay, this is for a general data set I am telling. So first, if you are taking any data set, first you will be seeing whether the data set contains any missing values. Then you will be seeing like if the data format as well as the data, if the data format is right. Okay, and then you will be seeing like whether the data is lying within the maximum minimum values, or are there any outliers. Okay, so actually the standard assumption will be like, actually it's like there should be no errors in the measurement of independent as well as the dependent variable. Then only you can fit the model, right? In the measurement you don't expect any errors. Okay, so it's like there should be no errors in measurement of independent and dependent variables. So I hope that you are clear with that. The relationship between the independent and dependent variable in a simple linear regression is described by. This is ABCD, you can give the answer. Okay, yeah, the answer is right. D, coefficient and intercept. Okay, the Pearson's correlation coefficient between two parameters is calculated to be 0.10. What can be inferred from the correlation coefficient regarding the relationship between the two parameters? So this is just Pearson's correlation. So anyway, it's like usually used when numerical variables are present. If you have some categorical variables or like ordinal variables, then you'll be going for Spearman or Kendall. I mean, these three are the ones that you have seen, and other correlation functions are also there. Okay, so here it was just 0.10 1 0. It's positive. From this you can see that it's positive and it's close to 0. So I think yes, I have got an answer. C. There is excessive weak positive relationship between the two variables. That's right. So okay then, so I think today's session we can stop here, right? Because maybe similar questions also you will be having in the present course. I haven't seen the present course questions, but still might be similar. Okay then, everyone, have a nice rest of the day. Thank you.